Let's try a problem. Kroger decides to raise the price of its milk from $2 per gallon to $3 per gallon. Very soon they notice a decrease in the quantity of gallons demanded, from 100 to 80. There are two questions that you'll need to answer with this. First, what is the elasticity of milk at this price point? And second, is milk elastic or inelastic? Well, let's look at our formula. Here we have percentage change in the response variable over the percentage change in the explanatory variable. We have to ask ourselves what y and x stand for. It seems that we're dealing with price and quantity demanded at this point. So this is a problem that deals with the price elasticity of demand. So y, the response variable, is always going to be the quantity demanded, because the quantity demanded changes in response to the change in price. Because they raise the price, fewer gallons are demanded. So let's look at the variables that we have and see what numbers we have. Our y's on top, the response variable, as I said before, is going to be the quantity demanded. Y1 is the old and Y2 is the new. The old is 100 gallons and the new is 80. And then for price, which is x, we move from $2 to $3. So now all that we have to do is take this formula, plug in the numbers, and simplify. On top we have 80 minus 100 over 100. And on the bottom we have 3 minus 2 over 2. Now this is going to be a negative number, and the whole fraction is going to be negative. This is always the case with price elasticity of demand, unless it's perfectly inelastic, because the higher the price, the fewer people will demand it. So to make things easier on themselves, economists like to always make this fraction positive. So we see 80 minus 100, which is going to be negative 20, but we'll just make it 20 for ease. So we have 20 over 100 on top, which simplifies to 1/5. And on the bottom, we have 3 minus 2, or 1 over 2, 1/2. To divide, flip and multiply. We have 1/5 over 1/2, which is equal to 1/5 times 2 over 1, or 2. I'm sorry. Equal to 1/5 times 2 over 1. So this becomes 2 over 5, or 0.4. And so the elasticity is 0.4. And because this value is less than 1 and greater than 0, milk at this point is price inelastic. So now the question is, should Kroger maintain this price change? Firms always try to maximize profits, which are denoted by an uppercase Greek letter pi. Profits are equal to revenue, the amount they bring in, minus the cost, the amount that it costs. And revenue is equal to the price of each one that they sell times the number that they sold, price times quantity. So let's look at the before and after. Before, they were selling 100 gallons of milk for $2 each, so their revenue was $200. Now they're only selling 80 gallons, but they're selling them for $3 each. So 3 times 80 is 240. So we can see that by increasing the price, their total revenue has increased. Combined with the fact that they would only need to purchase 80 gallons now to satisfy demand instead of 100, meaning that their costs would go down because they would have to pay less to the farmers and the producers of the milk. Their profits would probably increase, so this was a good move. But why does it work this way? Well, I'll introduce you to something called the total revenue test.